Okay, good day. So, welcome again to my channel. I'm Engineer Ernesto Prudentiado Jr. and we're going to continue to our discussion, integral calculus. So, this time we will move on to the next topic, logarithmic function. Okay, so what is logarithmic function? So, recall in your differential calculus, if you have this function, ln u, okay, and you wish to differentiate that, so this becomes what? du over u. Okay? So, and if you want to, and if you want this function to go back to its original equation, this one, you have to apply integration. Okay? So this will cancels out, and what is left on the left equation is ln u plus c equals integral of du over u. Okay? So you have now the function. If I will interchange this becomes du over u equals ln u plus c. Okay, this is now the formula for the integration of logarithmic function. Okay? Okay, let's jump to examples. So example number 1, integral of 2 over x dx. Okay, let's examine this. If this will qualify to our function or to our formula of du over u, which is equals to ln u plus c. Okay. So the denominator here would be our u. The du here is dx. Okay. So we have numerator dx. So therefore, this will qualify to this formula. The only problem here is there is a constant 2 at the numerator also. So we already know that we can factor it out. So therefore, we can rewrite this equation as 2 integral of dx over x. Okay? So this will now follow our formula, integral of du over u. Okay? So therefore, this is equals to what? 2 ln u plus c. Okay? So this is now our answer. So this is now our answer. Okay? So, by the way, no, if you ask, Sir, paano pag ginamitan ko yan ng power formula? So, ito yung mangyayari. 2x dx. So, paano pag ginamitan natin ito ng power formula? Okay? Pwede ba? So, let's see. So, integral, gagawin ko, i-move ko yung yung x to the numerator becomes negative 1 dx. Okay? So, recalling our power formula, u to the n du is equals to un plus 1 over n plus 1 plus c. Okay? So, this becomes 2 x negative 1 plus 1 over negative 1 plus 1 plus c. Okay? So, this becomes 2 x. What will happen to this? This becomes 0 over 0 plus c. So, our equation becomes nonsense because any number raised to 0 is 1 and 1 divided by 0 is undefined. So, therefore, this power formula cannot be used. Okay? Okay. So, it is clear that in this equation, we can only use our logarithmic formula. That is integral of du over u equals ln u plus c. This one. Okay, no other else. Okay, let's go to the example number 2. Example number 2 is the integral of 1 over 2x minus 1 dx. Okay. So, question, is this equation qualifies to our logarithmic formula? Okay, so integral of du over u equals ln u plus c. Okay, let's examine, no? So let u equals 2x minus 1. So therefore, du equals to, the differential of 2x is 2, and the differential of 1, which is constant, becomes 0. So this becomes 2 dx. Okay? So therefore, we can solve dx in terms of du. So we will just divide by 2, no? So du over 2. Okay? So if we substitute this becomes integral of 1 over, this becomes our u. Then our dx is equals to du over 2. Okay? So this one is a constant. I can factor out. So 1/2 integral of du over u. So this is now the same as this. Therefore, this will qualify. Okay, so integral of this is equals to ln u plus c. Okay, so go back to our original function. The value of u is equals to ln 2x minus 1 plus c. Okay, so we can finalize our answer by 1/2 ln 2x minus 1 plus c. So this is now our final answer. Okay, for example number 3, integral of secant y dy. Okay, so let's examine first if there is a formula of integral secant u du on our given list. Okay, so let's go to this LP. Okay, so this is the given list, no, of our integration. So secant, okay,
I know your eyes in the morning sun. I see you touch me in the pouring rain. And the moment that
so you cannot find here secant u du. So what you have to do here is to expand this function, secant y dy, multiply this by secant y plus tan y over secant y plus tan. So this function is just equal to 1. So there's no effect in our equation. Okay? So cross multiplying, this becomes secant squared y, because we have 2 secant y, plus secant y tangent y over secant y plus tangent y. Okay? So we must examine if still this function follows our integration of logarithmic function. So this one is du over u equals ln u plus c. Okay? So if this is my u, secant y plus tangent y, so what is my du? Okay? So you have to recall your differential calculus to get the derivative of secant y and tangent y. Okay. Before going into that, I want to teach you to memorize basic differential functions, no? So remember this, sec, tan, okay? Then cosecant, cosecant, cotangent. Okay, so this is just negative. Now, in differential calculus, the differential of d sec u, so this one becomes sec u tan u du. Okay, this one. Now, for the second part, the differential of cosecant, okay, cosecant u equals to negative cosecant u cotangent u du. Okay? So for this one, okay? Now, for this tangent, differential of tangent u is equals to, since we have 2 secant, this becomes secant squared u du. Okay? Now, let's go to the cotangent. The differential of cotangent u equals negative cosecant u du. But we have 2 cosecant, so this is squared. So that's how to memorize basic trigonometric function. Okay? So the key here is to memorize this one. Okay? This is just the same in memorizing integral of trigonometric function as I taught in video 2. Okay? So going back to the problem, so what is the differential of secant y? So here, secant u. So secant u is secant y tangent y dy, okay, plus the differential of tangent y, this one, so secant squared y dy. Okay, did you see that this is equals to this one, the numerator? So this secant squared y dy, this one, secant squared y, then secant y tangent y dy, this one, secant y dy tangent y, because we have dy here. Okay, so it's just the same. So therefore, this equation qualifies to our integration of logarithmic function. Therefore, this becomes integral of du over u is equals to ln u plus c. So, but what is our u? Secant y plus tangent y plus c. So, this one, this is our u, secant y plus tangent y. So, this is now our final answer. Okay, so but if you remember in video 2, so I already taught you how to memorize the formula of integration. So I will attach the screenshot of my lecture note. Okay, if we look into the list, so we have integral of secant u du. So we can use the formula to our problem number 3. Okay, so the answer is ln quantity secant y plus tan y plus c. Okay, so direct substitution, that is if you know how to memorize the formula. Okay, you can get right away the integration of our problem number 3. The integral of secant y dy, this one. Okay, so thank you for listening. Bye bye. God bless.